Hi there, and welcome to another update on the ongoing volcanic situation in Iceland. Today is Sunday, June 23rd. I am Geology Professor Shawn Willsey. Thanks for joining me. It is about 10:30 a.m. here, Mountain Daylight Time, and about 4:30 p.m. in Iceland. So we're going to do a brief update for today. Apologize, I was not able to do an update over the last few days. I had three field trip days here in southern Idaho with some YouTube viewers. Fantastic group, great situation. It was just fun all around, and I'll probably share some of those photos and maybe a few stories in a future either live stream or update. So I want to first start off with our update today by apologizing from my last update on June 19th. I was a little bit confused and reported the wrong location for the spillover, the lava spillover, the lava that spilled over the berm and that was threatening the power plant. I located that in this area here, and it's actually over in this area here. And I have an updated shapefile from this latest May 29th lava flow, thanks to David Gunzler, one of our viewers there. And so appreciate his work in sending me this. But just to be clear, and I knew it, right after I posted, I realized my error, but it's obviously there, and it takes a lot of work to kind of go back and re-edit a video and repost it and such. So I'm clearing up that error now. So hopefully folks are okay with that. But this is the location where the spillover has occurred. So this is the location and the focus of a lot of the mitigation efforts. It's only a kilometer or so away from the power plant. So this is obviously a big concern to the folks in Iceland. So they're continuing to battle this spillover that is continuing even as we speak, although it's quite slow. They are building also a second berm somewhere in this area here as a bit of a barrier to slow down any future spillovers, including the current one that's going on there. They all are also working to slow the lava with water. So there's efforts going on right now to spray water on the flows. That basically buys them some time while they build the berm. Realize that all these efforts, whether it's the berms or spraying water on it, I mean, ultimately you're not going to actually just like stop the lava. And it depends a little bit on how it's advancing. In this case, I feel like this is a pretty good application of using water because the spillover is quite slow. It's the type of lava flow that tends to be quite rubbly and slow advancing. And so I feel like those efforts are working in the intent that that's there, that they're just trying to slow the advance of the flow, not necessarily stop it outright. So we'll get to some of that here in a second. Let me show you just sort of the webcam view as it speaks right now. So you can see the road north-south through Grindavik. You can see the power plant infrastructure here in the foreground. The Blue Lagoon would be out of view down and to the left. And you can see some of the spray water going on here. And you can see where all the steam's coming up here. This is where the majority of the efforts are going on right in this area here. So building that second berm out ahead of the flow. You can see the spillover in this area over here. So let's, but just to show you that this is molten, I just took one of the webcams and went back, about 10, 11 hours so you can see when it was darker. So you can see the glow there. You can see the spray of the seawater in that location. Just to show you that there is molten rock or lava at the surface in this area. A little harder to see during the daytime, and not a lot of incandescence in that area. So this is and then going forward, there was a period where the weather was kind of socked in with clouds and such. And then moving forward a little bit more, you can see again that seawater, and then all this steam and volcanic gas that's coming off of this flow that they're working on. Cooling off. There's another one of the trucks there spraying the flow down. And then we just go to, looks like the camera's swiveled over at some point to a different area. So see the water being sprayed there. And then, yeah, just some of the construction work going on with the berm. Okay, so let's go to the Met Office update. And this is from yesterday, June 22nd. At about 6 o'clock in the evening, so not that old. The eruption seems to be over, and this is somewhat there's different reports that yes, it's over, no, it's not. And so right now we're kind of in that gray area where it doesn't seem to be definitive, but if nothing else, it seems to be winding down, if not, the last few gasps potentially of this eruption. So the activity it might take on this is the activity might be over in terms of seeing anything at the vent, but you could also have some of that magma rising, and instead of erupting out of the cinder cone, or excuse me, the spatter cone, which has been the primary vent, it may be just going directly into a tube system at the base and then feeding some of these flow lobes that are out away from the spatter cone, such as the one we see near the power plant. So the eruption that started on May 29th, let me make that a little bit bigger for you, seems to be over. Yesterday there was a little activity in the crater, and this afternoon there was no activity when Civil Defense flew a drone. Turbulence on nearby seismometers has also dropped and is now comparable to what was measured before the eruption began. However, it can still be expected for some time that older lava will continue to flow slowly along Selingerfeld on the north side, and that the defense wall L1 where the spills, where the lava has spilled over. I think that's the correct translation there. So even though we're not seeing eruptive activity at the primary vent, the lava that's currently in the system can continue to advance downhill, especially because it's pretty well insulated. If it's in a tube system or some sort of a crusted over thing, and that can move downwards. So what they have here is a photo from, let me zoom that one out a skosh. This is from the 21st, which was Friday. So Friday at 9:30 in the morning, you could see with the top-down view of the spatter cone, you could see fresh lava in the crater, although much diminished over what we've seen previously, including the last time I did a drone flight with NatureEye. There was a lot more activity in the crater. It was, throwing little bits of lava out. At that point, it was still, diminished activity over what we've seen in the past. But this picture from Friday might very well be the more or less the last true indicator that there was lava at the surface in the spatter cone crater at that time. And then the next photo here from the Met Office is from yesterday, the 22nd, at about noon. So basically within a little more than a 24-hour period, we went from that level of activity visible to this, where you can't see any distinguishable incandescent glow in the crater there. So if surface lava at the vent is your indicator of if an eruption is ongoing or has completed, then I guess you would come to the conclusion that the eruption is over. But if you are looking anywhere in the flow field or anywhere in the system for flowing lava, then you might argue that it's still ongoing, although it might again be in its sort of like waning phases. So those were the two photos here, and a little bit of an update from the 21st, which was Friday. Again, they had this photo here, pictures of the water that they were using to slow that a little bit. And then this little graph here, which just shows drop in earthquake activity over time. So that was another bit of evidence to show that the level of activity has decreased a little bit over since the eruption began on May 29th. Just a steady downturn in this seismometer here. So, and then we get to a much older update there. So earthquake activity, again, not much going on. We would expect these maybe to tick upwards a little bit once the surface activity has stopped and we start moving towards a period of magma moving into the subsurface, filling this shallow magma storage zone. We might start seeing a little bit of an uptick in these earthquakes in terms of their numbers per day, not necessarily their magnitude. And then it's going to probably take some time until the system's fully recharged and ready for another eruption. But we'll look at that here in a second when we get to the GPS data. Looking beyond just the last 24 hours to the last week, you can see, again, just not a lot of activity around the eruption site here. One or two earthquakes at best in the last week. A few over here near Fagerdalsfjall, somewhat to be expected, and a similar pattern to what we've seen in the past. And then I would argue that most of this just looks like typical tectonic seismic activity or noise, if you will, on the Reykjanes Peninsula and throughout the rest of Iceland. So nothing noteworthy here. We had a few earthquakes over here near Katla a few days ago, but again, like 4 or 5 earthquakes, probably related to the glacier and the ice more so than anything else. We would expect to see a lot more earthquakes concentrated over time if this was truly due to magma movement beneath the volcano and beneath the ice. So the GPS data, which we have often looked at, looks more or less like this here. If we look at the Svartsengi station, of course, here's our uplift going into April and May, culminating in the May 29th eruption, the eruption we're currently at the end of or near the end of. So there's that down drop in the elevation, a few days of what we would call deflationary trend, and then since then we've turned that around and this has become an inflationary trend. So this is evidence that magma is continuing to move into this shallow storage zone beneath the power plant, but at a much slower rate overall than what we've seen previously. You can see the slope of this data trend here of these points is significantly more shallow than this data cluster data points here. And again, we see those at other stations as well. Probably don't need to pull any of those up, but here's one of the other ones here, but you can see that same sort of trend in the data. So it's pretty consistent across the board from station to station. So our good friend and viewer, Bruce Garner in the UK, sent me another one of his graphs, and let me pull up over here his email so I can hopefully guide you through this a little bit better as best I can. Where is it? Here we go. So he has his spreadsheet out and plots this stuff up pretty nicely. And so this goes all the way back to October in terms of the timeline here. So October 2023, all the way, this projects out to past October of 2024. So the data ends right in here because we're in late June. But let's go ahead and just check this out real quick. So this is him taking the Svartsengi power plant GPS station data. So just this one station's data that is the main one we've been looking at because it's most directly over the magma body. And then this is the GPS height or uplift here. So there's each one of these down drops here in the data corresponds to a significant event in the system, either an intrusion of magma in the subsurface, like we saw with the November 10th intrusion, which was right after the big flurry of moderate earthquakes, or many of these correspond to actual eruptions, like this first eruption here on December 18th. So inflation is the trend going upwards as magma is accumulating in the subsurface, and then when it drops down and spikes down, that's the eruption. So that's lava leaving the subsurface and coming out to the surface. Following the eruption, we get a trend of data going upwards again as the system recharges with magma, and then a down drop when we see the eruption take place again. So each one of these spikes is either an eruption or an intrusion. So you can see several of these here, and most recently the May 29th eruption here. So there's the little bit of a trend of data, and what Bruce has tried to do here as best he can is use some analysis to model the rate at which magma is accumulating, the rate of uplift, and looking at how much it changed, because you can see each one of these little peaks jumps up the graph. It takes more uplift in terms of total elevation for between each eruption to trigger an actual eruption. And so we wouldn't expect the next eruption to occur at the same GPS elevation that we saw on May 29th. He is forecasting and predicting that somewhere between these two red lines up here on the graph. And so depending on the rate of inflation, and he's got two different trend lines here, one in purple, one in green, what we can then do, if you're having fun with this graph like I am, is then we can see where this trend line, these two dotted lines, intersect the red lines, and then we can drop down to the time component and see about when that would correspond in terms of an eruption date. And so it looks like at the soonest, using his modeling here, we might see something around the 8th or 7th or so of September, so early September. And at the other end of the spectrum, it might be a month or so later, early October, maybe the 6th or so, that we might see the next eruption in the area. Of course, this is all based on some different variables and assumptions. So take it with what you will, but it does at least give us a timeline and some rough ways to forecast, not predict. Remember, prediction involves giving a specific event and its magnitude, a date, a location, sometimes even a time. So we're not necessarily being that specific. We're just more or less looking at a window when we might see the next eruption based on the data we have, the behavior of the past, and then sort of extrapolating that data out a little bit. So thanks again, as always, Bruce. I enjoy kind of going over these, and I think a lot of viewers do as well. It gives us a good handle on what might be next. So I guess if you were trying to go see any sort of bit of eruptive activity or lava in Iceland this summer, it would look like you would have to possibly wait a little bit. Like I would not book that August trip just yet. I mean, if that was your sole goal, was to see an eruption based on at least this forecast model right here. So good job, Bruce. Thanks for that so much. Okay, so a few pieces of news and then we'll wrap this up. A couple bits of news, and as always, thanks to Amanda Joe over there in Iceland for sending me some of the headlines, keeping me up to date on what's going on. Incredibly important, so thanks as always to her. So article about, it's hard to say what will happen next. The lava is being cooled, but they kind of are just taking it hour by hour, not sure exactly what's going to happen. The lava goes over the defensive wall, they start fighting it, but obviously looking into the future, they're not sure exactly what's going to take place moving forward. So there we go, lights went off again. This was an interesting one here. Let me see if I can remember this one here. So the cooling of lava with water combined with the strength of the ramparts proved successful in holding back the lava that flowed over the ramparts there. It's a good experience for the future in the opinion of the public safety. I don't know. I mean, I just kind of read the headline and skimmed the article, so I don't want to, maybe I've misconstrued this a little bit, and there could be a little bit of language translation issues as well. I would maybe take some exception to that statement a little bit. The cooling of the lava and even the berms, while they have been successful thus far, I mean, ultimately, depending on the situation, you're not going to win the fight against the lava, but it can buy you some time. Hopefully you can redirect that lava. These berms and these defensive measures were never meant to actually stop the lava, but keep it out of this critical infrastructure area. So I would say that while it looks good right now, what they're doing, let's realize that the output of lava at the surface is either zero or very close to zero. So we're dealing with a system that doesn't have a lot of volume that's being produced. So it's a very small amount of lava dribbling over that defensive berm. So this type of mitigation makes sense, and I think it's appropriate right now. But I just wonder if that headline was a little bit misleading, and maybe that's all on me in terms of how I interpreted that. So, and I know full well that the Icelandic people and authorities, don't think that, oh yeah, we'll just shoot water on this and everything will be fine. I know they respect and understand the dynamics of the situation much more than that. So, and then our final bit of news here, and this is a bit of good news. So. Going back to the Google Earth file here. So of course, one of the big risks with any sort of eruption, where it's the ongoing one and the spillover here, or the next eruption, or 5 eruptions from now, any volcanic activity in this region, is of course the power plant and the critical role it plays in heating homes and providing hot water throughout the Reykjanes Peninsula. And so the very wise Icelandic folks have decided, well, we're going to do our best to save this, because this is what's important right now. But looking ahead, even though we might win a few battles here and keep this going for hopefully indefinitely, but at least a few years, we might ultimately lose the war, even though we've won a few battles. So we should probably start looking to see how we might supplement or possibly eventually replace this power plant. So they have begun efforts to drill other boreholes, excuse me, um, in some areas on the peninsula where the volcanic threat is much lower. So one specific area is over here near Keflavik in the airport. And so this next article I have here is about some of the exploration work they've done here. And so let me take you to the map first that shows, hopefully you can see that okay. I can zoom in just a skosh. And so you can see this is the tip of the peninsula. Um, the airport is just off the bottom of the map there. And then, so this part here, which has, you know, less likely to erupt. The rocks here are quite old. We definitely don't predict or forecast an eruption out on this part of the peninsula anytime soon. But this area, I need to zoom back out a little bit, is the area where they have been looking and exploring to see if there's hot water as a resource, a geothermal resource in that area. And so this article nicely kind of summarizes that during test drilling in the Rockville area between Keflavik and Sandgerði, at the beginning of the summer, a hole was found that provides between 30 and 40 liters per second of 70-degree hot water. They say this hole is successful and can make a difference. And so I think right now what they're at least hoping to do is this could be a backup. And so until they get a lot more, obviously you don't just build a geothermal power plant overnight. It takes some time. It takes the exploration work and all the infrastructure and all the piping that needs to go into that. But at least this could be used as a backup as we go into this next winter if anything happens with the Svartsengi power plant over here near where we've been seeing some of these eruptions. So that's good news. And again, not surprising. I've always been just impressed with Iceland's ability to just roll with the punches, move ahead, get what's done, what needs to be done, and plan as best they can for the future. So they're not perfect, not like anyone else, but I think they're doing as well as can be expected given the situation. So that's it for today. Hopefully you enjoyed this quick update. Looking forward, I'll be leaving soon again to go over to Europe on the 26th for a Rhine River cruise that my wife's been excited to go on. But I might do another update either Tuesday or Wednesday morning, depending on what's going on. We may also be going into a period where there's not a ton of news coming out of this part of Iceland. And if I have the time, I would like to kind of circle back to just looking at some of the lingering questions I've had about the rocks there. I'm trying to get some of the borehole data from Svartsengi, get access to that because I'd like to put together a more cohesive cross-section in this area because I'd like to understand myself, and maybe you'd be interested in understanding what the geology looks like beneath the power plant, because a lot of people have wondered why, if the magma body is sitting over here, why we're seeing eruptions, you know, a few kilometers to the east. And so just a couple things I've been thinking and wondering about. So we'll see you next time. Thanks again for your time and your support of the channel. And we might also do a live stream as well in the next few days. Just kind of depends on a couple things. In the interim, I will get a few other videos ready for you, so those will go out during the week or so I'm gone. But take care as always, and I thank you, and we'll see you next time. Bye.